Good morning, everyone, and welcome to this lecture. This is lecture number 12 in work, power, and energy. We are finished with work and energy. In this lecture, we'll have to look into one more aspect of circular dynamics and into one more aspect which is known as circular dynamics. Now, what do you mean by circular dynamics? Anyone? Do we remember what we had done in circular motion? Do we remember what was circular motion? Anyone? Do we remember circular motion? Anyone remembers what is circular motion? Yes or no? No one remembers circular motion? Say yes or no. Do you remember anything about circular motion?
Yes, sir.
Yes.
What do we remember about circular motion? What were the terms that we studied in circular motion? Tell me. What do we remember about circular motion?
Angular displacement.
What do we remember?
Yes, velocity will be tangent of the path.
There was a term known as angular displacement. Do you remember this term, angular displacement?
Sir.
Denoted by the letter delta theta. Final angular position minus initial angular position. Remember this? Angular displacement, when a particle is moving in a circular motion, it is going to change its position from, let us say, P to P dash. It turns through some angle. That angle is known as angular displacement. Do we remember this? Okay. What was the SI unit of angular displacement? What was the SI unit of? Yes?
Radians.
Good. The SI unit was radians. Dimension?
Dimensionless.
Dimension. It was dimensionless. What type of quantity was angular?
Scalar quantity.
Large angular displacement delta theta was a scalar quantity.
Smaller vector quantity.
Smaller angular displacement was a vector quantity. Do we recollect this? Okay. We collect this. That's good. That was the first thing that we had studied, angular displacement. And okay. Also, we must remember the relation between radians and degrees. Pi radians is equal to 180 degrees. Do we remember this? One revolution is equal to 2 pi radians. Do we remember this? Okay, I'll give you 1 minute to note this down. Do it fast. At the same time, we also had at the same time we had also seen that we had taken anti-clockwise as positive and clockwise as negative. Do you remember that? Anti-clockwise angle are taken as positive angles. We remember this? Okay, that was angular displacement. Everyone remembers it, right? Have you noted this down? Let me know once you are done. What was the second quantity that we had seen after angular displacement?
Average angular velocity.
We had seen angular velocity, and we had seen that we can consider them as two types. First one was known as average angular velocity, and the next one was known as yes. What were the two types of angular velocity that we had seen?
Inten-
One was
Instantaneous angular velocity.
average angular velocity, and we wrote it as omega in a bracket, omega in a dabba. And what was average angular velocity?
Instantaneous angular.
It was total displacement, total angular displacement divided by total time. Theta 2 minus theta 1 divided by t. What type of quantity was average angular velocity?
Scalar.
Yes, it was a scalar quantity. What was the SI unit?
Radian per second.
Good. SI unit was radian per second. What was the dimension?
T minus 1.
Dimension was t minus 1. Okay. Then what was the other type of angular velocity that we had seen? That was known as
Instantaneous.
instantaneous angular velocity. We write it as omega in this way. How did we define instantaneous angular velocity? It was the angular velocity at any instant. D omega vector was d theta vector divided by dt. Yes or no? And this was obviously a vector quantity. Vector quantity. Yes or no? Then we had seen if omega is constant, we call that motion as, what was the motion known as? If omega is constant,
Uniform circular motion.
very good. It was known as uniform circular motion, UCM. And in UCM, we had seen something known as time period and something known as frequency. Do we remember time period and frequency? Then your omega was 2 pi by t, or it was equal to 2 pi into f. Do we remember this? Yes or no? Okay. Then we had also seen the relation between tangential velocity and angular velocity. Do we remember that relation between tangential velocity? Velocity is always tangent. Between tangential velocity and omega. Do we remember that relation? Vectorly, that relation was, it was omega cross r, where r is the radius. Do we remember this? If I write it in the scalar fashion, tangential velocity was omega multiplied by r. Did we see that relation? Yes or no? Do we remember it? Omega into r. Vectorly, it was the cross product of omega with r. That was all that we had read about angular velocity. I'll give you 2 minutes to note this down again. Do it fast. What was the next thing that we had studied in circular motion? Yes. What was the next thing? No one remembers it? It was known as?
Angular acceleration.
Yes, it was known as angular acceleration, alpha. We'd also seen two types of angular acceleration. What was that? First one, average angular acceleration. We denoted it as alpha vector in a dabba. What was average angular acceleration equal to? Anyone remembers? Average angular acceleration. Total change in angular velocity divided
Total
by
change in angular acceleration.
what is omega 2 vector minus omega 1 vector divided by t, where t is your total time. Do we remember this?
Yes,
What
sir.
type of quantity was average angular acceleration?
Scalar quantity.
It was a vector quantity. What is the SI unit?
Radians per second square.
Radian per second square. What was the dimension?
T minus 2.
Then we had done the second type of angular acceleration, that was known as instantaneous angular acceleration. Alpha vector. This is the angular acceleration at any given instant. And we had seen this alpha vector is the omega vector by dt, rate of change of angular velocity. Then we had also seen acceleration. We had also seen relation between different accelerations. We had seen two types of accelerations. We had seen two types of acceleration. Just give me a minute. Yes. Do you see my screen? So we had seen average and instantaneous angular acceleration. Then we had seen the two types of acceleration. What were the two types of acceleration? We had seen tangential, tangential and normal acceleration. Do we remember tangential and normal acceleration? Tangential and normal acceleration. Do we remember tangential and normal acceleration? Yes or no? Tangential and normal acceleration. What was tangential and
Sir,
what was normal acceleration? If I just show you a small diagram, if I show you a small diagram, this was the diagram. This acceleration, the pink one, which is pointing towards the center, is known as the centripetal acceleration or the normal acceleration or the radial acceleration. Do we remember this? Centripetal or normal, it was pointing towards the center. So what was the centripetal or normal acceleration? Normal or centripetal or radial? Normal or centripetal or radial acceleration. What was this doing? What was the job of this normal or centripetal or radial acceleration? What was the job? It was changing the direction of velocity. Anyone remembers it?
Yes,
Akash?
sir.
It was changing the direction of velocity. Acceleration does two things. It changes the magnitude of velocity, it may change the direction of velocity. This acceleration was changing the direction of velocity. We remember this? Yes or no? We remember this?
Yes, sir.
Okay,
Yes, sir.
we call it centripetal or normal or radial. Now, if I write the equation of this centripetal or normal acceleration vectorly, it was equal to omega cross Vt. It was equal to omega cross Vt. That was the vector equation, if you remember. Or I can write them the scalar equation, the centripetal or the normal acceleration can be written as omega into V. That was equal to omega square into R. That was equal to V square by R. Do we remember this? Centripetal or normal or radial acceleration. You can call it any of these. Doesn't matter. It means the same thing. Then there was one more acceleration which was doing what? Which was changing the what? It was changing the magnitude of magnitude of velocity or speed. Do we remember that acceleration? What was that acceleration known as? What was that acceleration known as? That was changing the magnitude or the direction of velocity. Ah, that was changing the magnitude of velocity. What was that acceleration known as?
Sir, your voice is not clear. Video is also not clear.
What was that acceleration known as? That was changing the magnitude of velocity. What acceleration was changing the magnitude of velocity? Anyone remembers it? What was the acceleration called? that was changing the magnitude of velocity. That acceleration was known as tangential acceleration. Tangential acceleration. AT. Tangential acceleration AT. It was changing the magnitude of velocity. We remember this. It was changing the magnitude of velocity. I don't know how many of you remember it, but A tangential was written as alpha cross R in the vector form. Do we remember this vector form? It was written as alpha cross R. Anyone remembers it? Boys, I can't see you. Do we remember this? Or simply if
Yes,
you
sir.
just want to write the magnitude, you could write it as alpha into R. Alpha into R. Then these two were perpendicular to each other. And then we got the total acceleration. Then we got the total acceleration. Huh. With both these acceleration, we got the total acceleration of the particle. Anyone remembers what was the total acceleration? Total acceleration A vector. Does anyone remember how did we find out the total acceleration? No one remembers it. Okay. The total acceleration A, which was the rate of change of velocity, is given by A normal plus A tangential. Tangential acceleration together with normal acceleration. If I had to find out the magnitude of this acceleration, it was equal to under root of normal square, yeah, centripetal square plus tangential square. And do we remember this or we have forgotten all of this? How many of you remember this? Well, remember, I mean, if you forget this, that's not good. Then we can also find out this angle. Can anyone tell me how do you find out this angle? Theta, that this acceleration, total acceleration is making with the normal acceleration. Can anyone tell me how can you find out the value of this angle theta? Yes. Can anyone tell me how can you find out the value of this angle theta? Can anyone tell me how can we find out the value of this angle theta? Yes.
Omega by T.
Omega by t. Well done. Anyone else would like to try? Tan of this theta is given by the tangential divided by the normal. Write it. I'll give you 2 minutes. Please note it down. Okay then. Now we come to The dynamics of circular motion. Now, what do you mean by dynamics of circular motion? Dynamics of circular motion means that we are going to study forces that act on a circular motion. So we are going to study the dynamics of circular motion. Now we have seen that this acceleration in a circular motion is going to change either the magnitude of velocity, or it may change the direction of velocity, or it may change both. Now therefore you will have two types of forces acting on the body. You can call one force as the centripetal force, which is acting towards the center, and we can call one force as the tangential force, which is acting in the tangential direction. Do we understand this, what I'm saying? So whenever we are talking about the dynamics of circular motion, what is going to happen is the particle is going to move in a circular path. This is the example of a particle moving in a circular path. The center is O and the radius is R. Now, while moving in the circular path, at any point, it would have some tangential velocity, Vt. Now, at this point, any point, it would be acted upon by two forces. One may be along the velocity and the other may be perpendicular to the velocity. The force which is perpendicular to the velocity will be pointing towards the center. This force is known as the centripetal force. Centripetal force. Centripetal force. You can call this centripetal force as Fn or Fc, whatever you want. What is this centripetal force going to do? Can anyone tell me? What will this centripetal force do? What will this centripetal force do? Yes? What will this centripetal force do? No one knows it. The centripetal force
Make
will
a body to move in a circle path.
the centripetal force will change. Change what? It will change the direction of velocity. The centripetal force will provide the body with centripetal acceleration, and that centripetal acceleration will change the direction of velocity. If I write Fc will be equal to m into AC vectorly, centripetal force will be equal to mass into centripetal acceleration. Centripetal acceleration can be written as m into v square by r or vt square by r, or it can be written as m omega square into r. So that would be the function of this centripetal force. Then there would be a tangential force. There may be a tangential force, Ft. Centripetal force can be called as Fc or Fn or Fr. Doesn't matter. What will this tangential force do? What will this tangential force do? Anyone? Just 2 minutes before we have written it. What
Changes
will?
the magnitude of the velocity.
Yes, it will change the magnitude of velocity. It will change the magnitude of velocity. So I can write this tangential force Ft as m into at, mass into tangential acceleration, m into at. Or you can write it as m into alpha into r if you want to. Do we understand this centripetal force and tangential force? What it is going to do? Centripetal force is going to change the direction of velocity. Tangential force will change the magnitude of velocity. This is what we call dynamics of circular motion. We are talking about the forces acting on a path, on a particle which is in circular motion. I'll give you 2 minutes to note it down. Once you are done, please let me know. Well, the next heading is equation of forces in a circular motion. How will you make force equation in circular motion? Now remember, in any circular motion, we have to make equation in 3 directions if required. 3 directions will not be required. Only 2 directions would be good enough. So equations can be made, equations of force can be made in 3 directions. Out of these three, we only need to make any two. Any two is good enough. What are those 3 directions in which you can make equation? Which is the first direction in which we have to make the equation? Any idea? What is the first direction in which we can make the equation? We have talked about some direction just now.
Along the centripetal force.
Yes, the first direction would be not along the centripetal force, it will be towards the center. One direction, towards the center of the circle. Towards the center of the circle, what will you do? You will find out the net force. You will find out what is the net force towards the center of the circle. You will find out what is the net force towards the center of the circle, and that will be equal to mv square by r, or that will be equal to m omega square r. So that is the first equation that you can make. The first equation that you can make is towards the center of the circle. You will find the net force towards the center, and you can equate that force to mv square by r or m omega square by r, m omega square r. What is the second direction that we can make the equation?
Tangential.
Yes, along the tangential direction. You can make the second equation along the tangent. F net along the tangent. You can find out the net force along the tangent, and that will be equal to m into at. From there, you can find out the tangential acceleration. If the body has any tangential acceleration, you would be able to find out the tangential acceleration from this equation, which is made in the tangential direction. What is the third direction? If required, the third direction is, then we make force, then we make equation in perpendicular to the plane of circular motion. If required, you can make this equation in the third direction, and this third direction is perpendicular to the plane of circular motion. The circular motion is happening in the horizontal plane, you can make in the vertical direction. If it is happening in the vertical direction, you can make it in the horizontal direction. What would be the equation in the direction perpendicular to the plane? Remember, the circular motion is going to happen in the plane. So perpendicular to the plane, there should not be any force. Otherwise, the particle will not move in a circular motion. So in this case, the F net, the net force must be a zero. The net force in the perpendicular direction must be zero, because if there is any force, then the particle does not move in that plane. The particle does not move on the plane. The particle does not move on the plane. Motion does not remain circular. So these are the three directions in which you can make the equations of a body which is moving in a circular path towards the center, along the tangent, and if required, perpendicular to the plane. Do we understand this? So this is gone above our head saying bye bye. Okay, I'll give you 2 minutes to note this down.
Excuse me, sir. Can you explain third
Now we move
one?
on to the next heading, and that is motion in a horizontal circle. Motion in a horizontal circle. Anyone was saying anything?
Excuse me, sir.
Yes, Peter?
Can you explain the third one?
Yes, I will explain the third one, don't worry. We have to make equation in the perpendicular direction. When it comes, I will explain it, okay? Motion in a horizontal circle. Motion in a horizontal circle. Now, whenever a question comes of circular motion, you can make equation in three directions. One is towards the center, one is along the tangent. The third one, if required, in perpendicular direction. Circular motion is happening like this, perpendicular direction. That's it. Nothing else. Okay? Got it? Perpendicular direction. Is no very hard thing about it. We'll see it here in this question. Motion in a horizontal circle. We start with this with a question. Probably that will make us understand the concept. So the question goes like this. A block of mass 2 kg is tied to a string of length 2 meters. The other end is fixed. The block is moved on a smooth horizontal table with a constant speed of 5 meters per second. You have to find out the tension in the string. Since this is the first question, what I am going to give you is I'm going to give you a diagram as well. Now, this type of motion which is happening on the horizontal ground or horizontal table, this is the ground, any motion happening here, And if it is in a circular path, this will be known as motion in a horizontal circle. If the motion happens like this, it will be known as motion in a vertical circle. Do we understand? Horizontal plane, vertical plane. Any circular motion in the horizontal plane, it is known as motion in a horizontal circle. Now, since this is the first question, I am going to give you the diagram as well. So this is how the diagram looks. This is a top view. A body of mass m, which is 2 kg, is attached to a string of length 2 meters. The other end is fixed. This is the end where it is fixed. It is moving with a constant speed. You have to find out the tension in the string. I'll give you 2 minutes to try it. Let me know once you are done. Well done. The answer is definitely 25 newtons. How are we going to solve this? First, the first equation is made towards the center. Do we remember this? Towards the center. Now, towards the center, if I draw the free body diagram, there is only one force acting towards the center. Do we see that force? Yes or no? Do we see that force which is acting towards the center, boys? Do we see this force? Yes or no? Do we see this force? Free body diagram. That force must be equal to the centripetal force. There is only one force. So I get my first equation. T is equal to M, centripetal force, M into V square by R. M is given, V is given, R is given. You can get the value of tension here straight away. Do we understand this? Yes or no? Yes or no? Boys, do we understand this? Now, let us see the other two equations. Equation number 2, along the tangent. Now, along the tangent direction, which is the direction of this green line, this is the tangent. You can see there is no friction on ground. There is no force. Nothing happens on the tangential direction. So, do we understand this? There is no friction. If there was friction here, then there would be an equation in the tangential direction. That equation would have given us the tangential equation, tangential acceleration. From there, we would have found out the change in the magnitude of velocity. Do we understand this? So in this tangential direction, there is no net force. So force is equal to 0. There is nothing that is going to happen. Now the third direction also we can make the equation. Now the third direction is the perpendicular direction, which is the vertical direction now. Do we understand this? Vertical direction, plane of motion. Do we understand this perpendicular direction? This is this direction. Remember, the body is moving like this. The body is moving on this plane. On this plane, like this. Ding, 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 ding. The vertical direction is like this. Now, there the net force in the vertical direction should be 0. Now, if you talk about the force in the vertical direction, and I cannot draw it in the diagram, if I draw the force in the vertical direction, and I will show it to you here. If I draw the force in the vertical direction, this is the body of mass m. What are the forces acting on the body in the vertical direction? Tell me fast. Body is kept on this. What are the forces? One is the weight mg, which is downwards. Yes or no? Boys, do we understand this? One is the weight mg, which is in the downward direction. One is the normal reaction from the ground, which is in the upward direction. Now remember, there is no motion happening in the perpendicular direction. So the net force must be 0. Net force must be 0. It will give us one equation. What is that equation that you will get from this net force being 0? Tell me. What is the equation that I will get from this net force is equal to 0 in the vertical direction? Tell me fast. The equation that I will get will be N equal to mg, and that is the equation in the vertical or the perpendicular direction. Do we understand this, how I made the equation? Well done. That brings us to an end of this class. I hope everyone has understood the basics of circular dynamics. We will go ahead and solve some questions on this. We'll see some cases, and then we'll move ahead with with the end of the chapter on work, power, and energy. I hope everyone has understood this and all the doubts are clear. Yes or no? All the doubts are clear. Okay, then I'll see you tomorrow in the next class. Take care. God bless all of you. Bye bye.
Thank you, sir.